Hey, seventh graders. Today we are doing section 1.3, and I'm actually going to split this lesson into two parts. So today we're just going to talk about scientific notation. So this is where we will start. If you guys want to head to this page. And this is section 1.3. Our goal today is to be able to convert between numbers greater than 0 written in scientific notation and decimals. Okay, so scientific notation is used to write really small and really large numbers quickly. It's used in science, that's why it's called scientific notation. If they had to write out the distance to the moon or the size of a tiny cell, using all of the digits, it would take up a lot of room and time, and so they have scientific notation, which shorten things and leaves us with something that's easy to compare. And we'll go into that the next day. So an exponent, which what we did yesterday, shows the number of decimal places in a scientific notation that the decimal needs to be moved. So a positive exponent, we would move the decimal to the right. And a negative exponent would go to the left. Okay? The base is always 10 in scientific notation. Okay? Not in all exponents, but in scientific notation, the base is always 10. The coefficient, which is this, must be greater than or equal to 1 and less than 10. So it can't be 10, it has to be less than 10. So this is what scientific notation looks like. And we have 3 with positive numbers, 3 with negative numbers. Okay, and so we are going to put it in standard form. Standard form is the natural way to write a number. So it says move the decimal place to the right n number of times, where the n is the exponent. So this, our exponent is a 5. So we're going to move it to the right because it's positive. So if I start with 4.52 and I move it 5 times to the right, it looks like this. 1, 2, 3, 4, 5. And that's where your new decimal point is going to go. Okay, what happens here though with these little loop-de-loops that aren't filled in with a number, we are going to add zeros. So your new number is 452,000. You put the comma there and that's your answer. Okay, so let's try it again. We're going to move it to the right 6 times. So if I start with 2.346, I'm going to go to the right 6 times. 1, 2, 3, 4, 5, 6. You've got to fill in the zeros. My new decimal point's right here. 1, 2, 3. So 2, 3, 4, 6, 0, 0, 0. Remember, every 3 digits going to the left, you throw a comma in there. Helps us judge what that number looks like. Okay. The next one, we're going to move to the right 3 places. So I start with 9.87. I'm going to move 3 places, 1, 2, 3. Your new decimal point goes right here, and you add a 0. So 9870, throw your comma in, and that's your answer. Okay, on the other side of our paper, we have all negatives. So negatives are going to go the opposite direction. And I kind of like how this is written right here to the left, because now I can move it 5 places. 1, 2, 3, 4, 5. Okay, so my new decimal point's going to go right here. And again, these little loop-de-loos, we put zeros in. Notice how I don't have 5 zeros. Even here, it wasn't 5 zeros. It doesn't tell you how many zeros there are. It just tells you that that's how many decimal places to move. So your new answer is going to be 0.12342341. There you go. Okay, so our next one, we're going to move it 6 places. So 1, 2, 3, 4, 5, 6. That's where your new decimal point's going to go. Fill in your zeros. I like to always put my 0 before the decimal. 4, 5, 8, 6, 0, 4. And in those in those decimals, there's no commas. But do you see how much nicer it looks than writing this all out? We just have this number here. Okay, and our last one here, we're gonna move it -3. So 1, 2, 3 spots. You're gonna put your decimal and you add just 2 zeros. So 0.00723353 is your final answer. Okay, so that's how we take it from scientific to standard. This is standard, these ones are scientific. Okay, so now we're going to turn the page. Now we're going to turn it from standard to scientific. Okay, so that's where we have to follow some of those rules from before. We're going to place a decimal point so the number is between 1 and 10, not including 10. Draw loops from the old decimal point to the new, and count your loops. Okay, so generally the other thing is, if it's a big number, positive exponent. Excuse me. Small number, negative exponent. So I'm going to kind of jot that down here. Large number, positive exponent. Small number, negative exponent. Okay, so now if it's a whole number, there's no decimal point here, but there's an understood decimal point right here. So I have to make this a number that's smaller than 10 but greater than 1. So I know my decimal point is actually going to go right here. So I'm going to make my loop-de-loos. 1, 2, 3, 4, 5, 6. So I moved 6 places. So this turns out to be 4.568. You can drop the zeros times 10 to the 6th. Okay, so now I can do my other one. My decimal point you can see right here. So I have to move it to make a number that's smaller than 10 but greater than 1. So I can't move it here because it'd be 0.9. 1, 2, 3. So I have 9.7 times 10 to the 1, 2, 3. I moved 3 places, but I moved to the right. I made this a bigger number. This is a negative. So let's try it on these ones. Again, my understood decimal point on these nice big numbers are there. So I'm going to move it. I know that I'm going to put it here because 7.6 is greater than 1 but less than 10. 1, 2, 3, 4, 5. So it's 7.64. I can drop the zeros times 10. It's always times 10. And I moved it 1, 2, 3, 4, 5 places. Positive 5. Next one, I'm going to put it right here because 9.8 is greater than 1 but less than 10. And I'm going to move it 1, 2, 3, 4, 5, 6, 7. So it's 9.8 times 10 to the 7th. Big numbers, positive exponents. Now we're going to do these smaller numbers. On this one, I just have to move it 1 place actually. Because 9.8 is greater than 1 but less than 10. And so I only moved it 1. Oops, I goofed. Okay, I was talking and writing. 9.8723. I can't forget those numbers. And then it's only to the -1. Sometimes my talking and writing doesn't always work out perfectly. Next one. I'm going to put it between the 6 and the 7 because 6.7 is greater than 1 but less than 10. 1, 2, 3. So it's 6.784 times 10 to the negative third. Okay, hope you guys are doing good. Okay, so the next question, say, are the following written in scientific notation? I want you guys just to take a second and look at that. Remember, the first number, the coefficient, has to be greater than 1 but less than 10. So this part, we're good. And then it's always a 10 to an exponent, so we're also good. So we'll say yes. Okay, the next one, is this one written in scientific notation? And we're gonna say no. Why not? No, because, and this is my shorthand for because, B/C, because 61.3 is greater than 10. Okay, we still have the exponent, the negative exponent's okay. Make sure, negative exponent doesn't mean a negative number. That's one little other thing that I wanted to point out. Okay, the last one here. What about this one? And we're gonna say no because of that coefficient. And I'm gonna say no because 0.238 is what? It is less than 1. And that's one of our rules. It can't be less than 1. It has to be greater than 1 and less than 10. So this is just to get you guys started. I hope that makes sense. And we will do some work with this today in class. Thanks.